Winds roar like a banshee across an alien desert, forcing a crew of astronauts to abort their mission. But in their desperate escape, they leave one of their own behind. Mark Watney, presumed dead, is very much alive, and he's stranded on Mars. With limited supplies, no immediate hope of rescue, and a hostile planet outside every airlock, Watney doesn't panic. He calculates. He improvises. He survives. But here's the real question. Could any of this actually happen? Could a single human, armed with science and sarcasm, truly endure on the red planet? Today, we journey into the real science behind the Martian. First, Mars. Mars is no gentle neighbor. Its thin atmosphere, composed almost entirely of carbon dioxide, offers no protection from radiation or micrometeorites. Daytime temperatures might touch -20 degrees Celsius near the equator, but plunge to -70 degrees Celsius at night. There's no breathable air, no liquid water on the surface, and barely enough pressure to boil your blood. In Andy Weir's novel, a ferocious Martian storm knocks out communications and leads to Watney being left behind. Visually dramatic, sure, but is it plausible? Not quite. Mars's atmosphere is just 1% as dense as Earth's. Even at 100 miles per hour, the winds wouldn't pack the punch to topple antennas or launch debris like a hurricane might on Earth. It's more like being in a foggy, dusty breeze than a sandblasting apocalypse. That said, Martian dust storms are real, and they are massive. They can engulf the entire planet for weeks, block out the sun, and cause temperatures to plummet. While they won't blow you away, they can bury equipment and cripple solar panels, something Watney grapples with later. Another unseen threat? Radiation. Mars has no global magnetic field, exposing the surface to cosmic rays. A long-term stay like Watney's would increase cancer risks significantly. NASA is actively studying underground habitats or radiation-shielded habitats for this reason. 2. Farming on Mars, the potato problem. Watney's breakthrough moment comes not from rocket science, but agriculture. Realizing his food supply is catastrophically short, he decides to science the shut-tea out of his situation by planting potatoes. Here's where things get interesting. Mars soil, more properly called regolith, does have some of the basic minerals plants need: nitrogen, potassium, magnesium. But it also contains perchlorates, toxic to humans and potentially to plant life. Unless removed or neutralized, Watney's crops would fail. But there's hope. Experiments on Earth using Mars-like soil, like NASA's Mars regolith simulant, show that with careful nutrient balancing and filtration, plants can indeed grow. Then comes the elephant in the room: human waste. Watney fertilizes his crop with the crew's stored feces. Gross? Yes, but logical. Human feces are nutrient-rich. Composting it first would reduce pathogens, but time was not on Watney's side. In real life, NASA is exploring similar closed-loop systems where waste becomes fertilizer and water is recycled endlessly. And what about water? Watney uses a dangerously improvised method: burning hydrogen to make water vapor, then condensing it. This is risky, explosive chemistry, but technically accurate. The ISS uses a safer, controlled process called the oxygen generation system, which splits water into oxygen and hydrogen, then safely vents or stores the byproduct. 3. Life support systems, DIY astronaut style. Breathing on Mars is not just about not dying, it's about surviving with precision. The HABS oxygenator and water reclaimer are inspired by real tech used on the International Space Station, ISS. Electrolysis of water splits H2O into hydrogen and oxygen, which astronauts then breathe. The water reclamation system captures sweat, urine, and exhaled vapor and recycles it. In space, every drop counts. Watney's ability to patch his damaged helmet and hab with duct tape seems absurd, until you realize how much NASA relies on quick, patchwork fixes. Remember Apollo 13? A real-life disaster narrowly avoided by astronaut ingenuity and literal duct tape. Watney's methods echo that very ethos: work with what you've got, or die. His EVA suits, airtight patches, and scavenged materials wouldn't pass safety protocols on Earth. But on Mars, with death minutes away, they might just be enough. 4. The rocket science, orbits, launches, and that Iron Man stunt. Much of Watney's fate hinges not on his plants, but on orbital math. His only hope lies in reaching Ares 4, a distant MAV, Mars ascent vehicle, and launching to intercept Hermes, his crew's return ship. Rendezvous in space is not simple. Even the tiniest miscalculation in velocity or timing could leave Watney stranded in deep space. The novel cleverly uses real principles of orbital mechanics to plot his rescue. Andy Weir, a software engineer, built orbital simulation programs to get it right. Could Watney manually strip the MAV to reduce weight and launch? In theory, yes, but not safely. NASA's current Mars mission concepts rely on pre-built ascent vehicles and return capsules, many of which are still conceptual. The most dramatic moment: Watney piercing his suit to propel himself toward Hermes like a human rocket. Newton's third law supports the idea. Every action has an equal and opposite reaction. But in reality, the pressure difference would likely spin him uncontrollably and lose oxygen fast. Still, it's a great example of sci-fi drama wrapped in real physics. A real-world case of interest is that of astronaut Ed White. In 1965, astronaut Ed White manually maneuvered using a handheld jet gun on a spacewalk. Real, but far more controlled. 5. NASA protocols and Earth's response. Realistic. One of the film's most accurate portrayals is the Earth-side response. Scientists at NASA scramble to re-establish contact, strategize solutions, and ultimately collaborate with China's space agency. Real-world NASA is a meticulous machine. Any manned mission includes backup plans, redundancy layers, and contingency protocols. The communication delay with Mars, roughly 4 to 24 minutes each way, is real. It means you can't joystick a rescue, you can only plan well. The depiction of bureaucracy and innovation working together, while dramatized, is rooted in truth. NASA does hold long meetings, endless calculations, and highly compartmentalized teams. But when push comes to shove, they act fast. Apollo 13 is proof. And the China subplot. Politically aspirational, perhaps, but technically plausible. China's space agency is advancing rapidly, and international collaboration has precedent, as with the International Space Station, ISS. 6. Human resilience. Could you survive on Mars? Beyond gadgets and numbers lies the heart of the story: resilience. Mark Watney is no superhero. He's a botanist and engineer with a foul mouth and an unstoppable drive. His survival hinges not just on knowledge, but on attitude. Psychologists studying long-duration isolation missions, from Antarctic bases to submarine deployments, note that humor, routine, and purpose are key. Watney uses all three. He records logs, tells jokes, and keeps busy. His sarcasm isn't just comic relief, it's mental armor. This is backed by real astronaut experience. Chris Hadfield, who spent months aboard the ISS, often spoke of the psychological toll of isolation. Structured schedules, music, and humor helped maintain crew morale. So, could you survive Mars? Only if you combine technical skill with unshakable spirit, and perhaps a few disco tracks. Conclusion: what the Martian gets right, and why it matters. Andy Weir didn't write fantasy, he wrote possibility. The Martian takes a near-future scenario and pushes every boundary of known science without tipping into magic. Yes, it simplifies. And yes, it bends reality for drama. But it never breaks it. It shows us that science isn't just formulas and lab coats. It's survival. It's hope. It's the will to adapt when everything says you're done. NASA called it the most realistic space film ever made. Scientists praise its detail. Teachers use it to inspire students. And readers see themselves not in a space marine or a chosen one, but in a man armed only with brains, tape, and potatoes. In the end, The Martian reminds us, you don't need to be perfect to be heroic. You just need to keep working the problem. And that, perhaps, is the most realistic part of all.